Hello, math learners! Our lesson for today is about functions. This is the Learning Pocket Concept Map for this week. Functions have basic concepts and representations, which will include evaluation of functions, operations on functions, composition of functions, and applications of functions. For today's session, we will focus only on the basic concepts and representations of functions. We will be having focus questions. The first one is, how will you relate to your everyday life to functions? And how can you make your relationships functional? The learning objectives will be, you are expected to represent real-life situations using functions and relations. Define relations and functions. Identify the different representations of relations or functions. And determine whether the given relation illustrates a function. Consider the four pictures here. These pictures show relationships of God's creations. How do you consider the relationship of the family in picture number 1? What about the relationship of the couple in picture number 2? What about the relationship of the roots in picture number 3? And what about the relationship of the lions in picture number 4? As you can see, not all relationships are functional. Let us take a look at number 1. How do you consider the relationship of the family? Is it functional or not functional? And the answer is functional. What about in number 2? How do you consider the relationship of the couple? Is it functional or not functional? It is not functional. What about the relationship of the roots? Is it functional or not functional? The answer is functional. And in number 4, how do you consider the relationship of the lions? Is it functional or not functional? And the answer is not functional. Now, how can you make your relationships healthy and functional? To your family, friends, neighbors, and to all God's creations around you. How will you take care and show respect to God's creations? Now in math, we also have relationships of numbers, which are functional or not. So, let us go now to the main topic. In math, the relationships of two or more numbers or quantities are called relations. Whereas relationships of two or more numbers or quantities that make sense are called functions. Look at the diagram. Then we can say that all functions are relations, but not all relations are functions. Let us recall the definition of a relation. How do you define the word relation? A relation is an association of an individual or object with another individual or another object. In math, how do you define the word relation? Relation is any set of one or more ordered pairs. What about function? How do you define function? Function is a special type of relation wherein no two ordered pairs have the same abscissa. And let us recall abscissa and ordinate. Abscissa is the x-coordinate of an ordered pair, while an ordinate is the y-coordinate of an ordered pair. For example, the ordered pair with coordinates 4 and 8. The abscissa is 4 and the ordinate is 8. And this ordered pair with coordinates -2 and 0, the abscissa is -2 and the ordinate is 0. Now tell whether each relation is a function or not. Number 1. Set A is equal to the set of 4 ordered pairs. The first ordered pair with coordinates 1 and 2, the second with coordinates 2 and 4, the third one 3 and 6, and number 4 with coordinates 4 and 8. How do you consider this relation? Is it a function or not a function? And the answer is a function. Because as you can see, no two ordered pairs have the same abscissa. Number 2. Set B is equal to the set of 4 ordered pairs. How do you consider this relation? Is it a function or not a function? And the answer is not a function. Looking at the ordered pairs, you can see that the first ordered pair and the third ordered pair have the same abscissa. Number 3. Look at the arrow diagram. We have set A with elements A sub 1, A sub 2, A sub 3, A sub 4. Then set B, B sub 1, B sub 2, B sub 3, and B sub 4. A sub 1 is paired with B sub 1, A sub 2 is paired with B sub 3, A sub 3 is paired with B sub 2, and A sub 4 is paired with B sub 4. Then how do you consider this relation? Is it a function or not a function? And the answer is a function. Because if you are going to express this in a set of ordered pairs, then we can see that no two ordered pairs have the same abscissa. And number 4, we have a table of values. The values of x are 1, 2, 3, and 4. And the values of y, we have 1, 4, 9, and 16. If we are going to express this in a set of ordered pairs, then we will have 1, 1, 2, 4, 3, 9, and 4, 16. So how do you consider this relation? Is it a function or not a function? And the answer is a function, because no two ordered pairs have the same abscissa. Next, let us have the different representations of relations or functions. The first one is we can represent a relation or a function by using a set of ordered pairs. For example, let us have this relation. The abscissa is 1 greater than the ordinate. So let us have this set of ordered pairs. We have 2 and 1, 3 and 2, 4 and 3. Consider the first ordered pair. The abscissa is 2. The ordinate is 1. And 2 is 1 greater than 1. Look at the second ordered pair. The abscissa is 3 and the ordinate is 2. So 3 is 1 greater than 2. And the third ordered pair, we have 4 and 3. 4 is the abscissa, which is 1 greater than the ordinate 3. And how do you consider this relation? Is it a function or not a function? The answer is a function, because no two ordered pairs have the same abscissa. Let us have the second representation using a mapping diagram. For example, we can represent a relation using an arrow diagram. So, look at this. We have set C with elements 2, 4, and 3. Set D with elements 20, 30, and 40. 2 is paired with 20 and 40. 4 is paired with 40. And 3 is paired with 30. Expressing this in a set of ordered pairs, then we have 220, 240, 440, and 330. Study the given ordered pairs. So how do you consider this relation? Is it a function or not a function? And the answer is not a function, because 2 corresponds to 20 and 40. We have 2 ordered pairs with the same abscissa. Now, a function is also a rule of correspondence between 2 non-empty sets, such that to each element of the first set, there corresponds one and only one element of the second set. And talking about correspondence, we have three types of correspondence. And what are these types? The first one is one-to-one correspondence. The second is one-to-many correspondence. And the third one is many-to-one correspondence. Let us have example for each type. Number 1. The one-to-one correspondence. You are given set A with elements A, B, and C. Set B with elements 2, 5, and 9. A corresponds to 2, B corresponds to 5, and C corresponds to 9. And how do you consider this relation? Is it a function or not a function? And the answer is a function. Because if we have these ordered pairs, we have A2, B5, and C9. And we can see that no two ordered pairs have the same abscissa. Let us have the next one, the one-to-many correspondence. You are given set C with elements X, Y, Z, set D with elements 10, 15, 18, 26. X corresponds to 10, and still X corresponds to 15. Y corresponds to 15, and Y corresponds to 18. Z corresponds to 18, and Z corresponds to 26. How do you consider this correspondence? Is it a function or not a function? And the answer is not a function. And why? If we are going to list down the ordered pairs, then we have X10, X15, Y15, Y18, Z18, and Z26. X is being repeated, Y is repeated, and Z is repeated. So that is why we consider this as not a function. And lastly, we have the many-to-one correspondence. Given set M with elements 6, 1, 2. And set N with element 4. 6 corresponds to 4, 1, and 2 corresponds to 4. And how do you consider this correspondence? Is it a function or not a function? And the answer is a function. Listing down the ordered pairs, we have 6, 4, 1, 4, 2, 4. No two ordered pairs have the same abscissa. And we call this as a special type of function. In real life, if the number 4 there is represented by a single child, 6, 1, and 2 are the supporters of that single child. Supposing 6 is the father, 1 is the mother, and 2 is the grandma, and they are supporting that particular only child, supporting financially as well as emotionally, then the life of that only child is very functional. That is why we consider also this many-to-one correspondence as function. Let's proceed. Let us have the other representation of a relation or a function using a tabular form. Relation can be described by a table. For example, the first column of the table, we have the Filipino heroes. And the second column, the date of birth. Jose Rizal was born on June 19, 1861. Andres Bonifacio was born on November 30, 1863. And Apolinario Mabini was born on July 23, 1864. Converting this in a set of ordered pairs, we have Jose Rizal, June 19, Andres Bonifacio, November 30, Apolinario Mabini, July 23. So how do you consider this relation? Is it a function or not a function? And the answer is a function. Because as you can see, no two ordered pairs have the same abscissa. Let's proceed. We can represent a relation or a function using graphical form. For example, consider this graph. If we're going to cite 3 points like 1, 1, a point with coordinates 2, 0, and a point with coordinates 4 and -1. How do you consider this graph? Is it a function or not a function? And this is a function because no two ordered pairs have the same abscissa. Look at the second graph. Citing 3 points, the first point with coordinates -4, -1. Second point with coordinates 0, 3. And the third point with coordinates 0, -5. So how do you consider this graph? Is it a function or not a function? So the answer is not a function. Looking at the second ordered pair and the third ordered pair, then they have the same abscissa. Now, aside from citing ordered pairs, one can easily determine whether it is a graph of a function by using the vertical line test. All you have to do is to draw a vertical line passing through the graph. A graph of a mathematical relation is a function if any vertical line drawn passing through the graph intersects the graph at exactly 1 point. Let us go back to the given examples. Look at the first graph. Aside from citing points, then let us use the vertical line test. Draw a vertical line like this. And this is the point of intersection. And there is only 1 point of intersection. That is why we consider this as a function. By the way, you can draw the vertical line anywhere as long as it crosses the graph. Then, let us look at the second graph. If we are going to draw a vertical line like this passing through the graph, then this point is the point of intersection of the line as well as the graph. And still, there is another point of intersection. That is why we consider this as not a function, because there are 2 points of intersection. Do you have questions? There is none. Let's proceed. And what are the 5 representations of relations or functions? The first one, we can use set of ordered pairs. Second, using mapping diagram. The third one, using a tabular form. The fourth one, by using a graphical form. And the last one is using mathematical equations or formulas. And I will give you now to Mr. Baluran to give you more examples.
Good day, math learners. By the way, I am Mr. Donald V. Baluran, and I am going to give you more examples on functions. But before anything else, let us have to review first the definition of function. Okay. So when say function, it is a relation in which each element of the domain is paired with exactly one element of the range. It is a special type of a relation wherein no 2 ordered pairs have the same abscissa. Please do remember the highlighted phrase so that it will be easy for us to identify a function in different forms of relation. Determine each given relation if it is a function or not. So let us try to identify this one. Number 1. Okay. In this illustration, the birth month of Mr. Baluran is July. The birth month of Miss Bontong is January. The birth month of Miss Cosette is July. And the birth month of Miss Cantillas is December. Now, is this a function or not a function? Okay, this is a function. What makes this one a function? As you can see, in this group, teachers in sacks represent the set of abscissas, and their birth month is considered as the set of ordinates. This is a function because no 2 ordered pairs have the same abscissas. Okay, number 2. Is this a function or not a function? Okay, this is a function. What makes this one a function? We have these ordered pairs, negative 3 and 4, negative 2 and 6. We have 2 and 6, 3 and 4. Now the abscissas are negative 3, negative 2, 2 and 3. This is a function because you cannot see having the same abscissa. They are unique, and that makes it a function. Okay, number 3. Is this a function or not a function? Okay, not a function because as you have seen, we have the abscissa 1, negative 1, 1, and 5. And they have the same abscissa. Am I right? And this is 1. And this is not a function. How about number 4? Is this a function or not a function? Okay, this is not a function. Okay? Because according to the definition of the function, exactly one element of the range. as you can see in this illustration or this table, okay, our x value, which is 1, is being paired with two elements of y, which is positive 1 and negative 1. Okay, same here in 2 is being paired with positive 4 and negative 4, 3, positive 9 and negative 9, and so on. Or to have a better understanding regarding about this, okay, so we have 1 is being paired with positive 1. 1 is being paired with negative 1, which is considered as having the same abscissa. Same here, so 2 is being paired with 4, 2 is also being paired with negative 4, having the same abscissa, which is 2. And so on. That makes this one not a function. Okay. For number 5, okay, we have Manila, Kuala Lumpur, Jakarta, Hanoi, and Bangkok. This is the set of the capital cities in Asia. And this is the set of the countries in Asia. So, Manila is the capital city of the Philippines. Kuala Lumpur is the capital city of Malaysia. Jakarta is the capital city of Indonesia. Hanoi is the capital city of Vietnam. And Bangkok is the capital city of Thailand. Now, is this a function? Okay, this is a function because no ordered pairs having the same abscissa. And in mapping of the diagram, we call this one as one-to-one correspondence. Okay, that makes this one as a function. Next, for number 6. Okay, set D having the elements of x sub 1, x sub 2, x sub 3, x sub 4. Now, set R having the elements of y sub 1, y sub 2, and y sub 3. So please observe this one, this pairing. What have you observed? Is this a function or not a function? Okay, this is a function. What makes this one a function? No two ordered pairs have the same abscissa. For number 7, okay, this one, a sub 1 and a sub 2 are the elements of our set D. B sub 1, B sub 2, and B sub 3 are the elements of set R. Okay. Is this a function or not a function? Okay, not a function. What makes this one not a function? Because a sub 1 is being paired with b sub 1 and b sub 2. According to the definition of the function, the domain, which is the set of abscissas, is paired with exactly one element of the range. Okay? And that makes that one not a function. For number 8. Okay. We have a sub 1, a sub 2, and a sub 3 are the sets of, or are the elements of set D. B sub 1 and B sub 2 are the elements of set R. Is this a function? Is that a function? Okay, not a function because a sub 3 is not paired to any element of R. That is why it is not a function. Number 9. Okay, the ordered pairs are 2, 4, 3, 8. This is 4 and 16, 5 and 32. Is this a function? Okay, this is a function because the abscissas are 2, 3, 4, and 5. No ordered pairs have the same abscissa. Is that clear? Okay. Number 10. Is this a function? Okay, not a function because there are ordered pairs having the same abscissa, which is 5 and 2 and 5 and 3. Okay, that is not a function. Okay, how about that? Is this graphical illustration a function? Yes, this is a function. But what makes this one a function? Okay, we have to consider this process. We will be using the vertical line test. According to the vertical line test, if you are going to draw a vertical line, just like this one, the red one, that passes through the graph and intersects at one point. Okay, how many points? There is 1 point. Then it is called a function. That is the indication of a function in a graphical illustration. Next, for number 12. Okay, is this a function? Not a function. What makes this one not a function? Okay, so again, use the vertical line test. And according to vertical line test, okay, this vertical line passes through and intersects at how many points? Okay, there are 2 points. That makes this illustration not a function. To make it a function, how many points? There is only 1. But in this illustration, we have 2 points. That makes that one not a function. Okay, for number 13. Is this a function? Yes, this is a function. Same procedure. Use the vertical line test. And you have seen here, the vertical line passes through and intersects at how many points? There is only 1 point. That makes the illustration a function. Number 14. Is this a function? Yes, still it is a function. Okay, use the vertical line test. And there is 1 point as their intersection. And that makes it a function. Okay. Number 15. Is this a function? Okay, this is not a function. Use the vertical line test. And how many points are there that this vertical line passes through our graph? There are 2 points. And that makes that one not a function. Number 16. What if we have this equation? Y is equal to x squared plus 2. Is this a function or not a function? Okay, this is a function. What makes this one a function? If you're going to substitute or assume the values of x as 1, 2, 3, and 4, okay, assume the values of x as 1, 2, 3, and 4, and then substitute the value of x with 1. Okay, that makes it 1 squared plus 2, and that is 3. Am I right? Okay, 2. 2 squared plus 2 squared, that would be 4. 4 plus 2, that makes it 6. And if we have 3, substitute the value of x, which is 3. 3 squared plus No, 3 squared, that would be 9. Plus 2, that makes it 11. Next, 4. Okay, substitute the value of x with 4. 4 squared, that would be 16 plus 2. The answer would be 18. Okay, as you can see, for every value of x, there is one value associated with y, and that makes it a function because there is no two ordered pairs having the same abscissa. Okay, number 17. What if we have that? Y squared is equal to x plus 2. Is that a function or not a function? Okay, this is not a function. Why? The solution is, okay, we have y squared is equal to x plus 2. Let's try to substitute x with 1. So it will become y squared is equal to 1 plus 2. Or y squared is equal to 3. In order to get the value of y, we are going to use the square root property. Okay, so square root properties. And if you are going to use square root property, the right side of the equation should have positive and negative. Okay, so we have square root of y squared. The answer would be y is equal to positive or negative, positive and negative square root of 3. This is our answer. And if you are going to put that one here in our table, okay, so in our value of x, which is 1, there are how many elements? 2 elements. That makes it not a function. Okay, so also if you're going to get the value of y using the value of x, which is 2, you will be getting positive 2 and negative 2, and so on. So to have a clearer understanding, it can be like this as well. So 1 square root of 3, 1 negative square root of 3. We have 2, 2, 2. That makes it not a function. Is that clear? Okay. So I will give you a certain formative assessment in order for you to test your understanding about identifying function in different forms of relation. So try to answer this one in your own, and we will send you the answer key to verify your understanding about this lesson. Okay, thank you and have a good day.
Thank you for watching this video.